Hello friends, welcome back, hearty welcome to you. In this session, we will see 10th grade trigonometry chapter introduction and little bit of what are those trigonometric functions, how to understand them and how to calculate them. Now in our channel, we have done a playlist on trigonometry 10th grade. In playlist, you can see that was done 11 years ago. And maybe we should revisit again that chapter, and maybe I can explain a little bit better than earlier 11 years ago with the experience whatever I gained in giving math tuition every day for last 12 to 13 years. So this is strictly 10th grade trigonometry, and you are advised to watch this video if you are a student of 10th grade and you are newly learning the chapter trigonometry. Our scope will be strictly 10th grade. Let's go ahead and start. Okay, good. Now let us say we have a right angle triangle. A right angle triangle is a triangle in which one angle is 90 degrees. Our scope in 10th grade is always with respect to right angle triangle only, and all the angles whatever we are going to learn here, they all will be between 0 to 90 degrees. Now suppose you have a right angle triangle and let us say the sides of them are 3, 4 and 5. Now if you see what are the different combinations, how you can write down the ratios of the sides of this right angle triangle, I see that I can write AB divided by AC. That means I can also do reverse of that, AC by AB. Then I can do BC by AC. Then also I can do AB by BC. So if I can do BC by AC, I can also find out what is AC by BC and AB by BC. So we have BC divided by AB. Now these are the only 6 combinations how you can find out the ratios of them. So AB by AC, AB by BC, then BC by AB, BC by AC, AC by AB, AC by BC. There are only 6 combinations we have. Now, suppose they have given us a triangle, then we want to find out these values. In this scenario, what it will be? AB by AC will be 3 by 5, 4 by 5. This will be 3 by 4. This will be 5 by 3. This will be 5 by 4. And this will be 4 by 3. When we started only, we said very clearly that the first 3, whatever we are writing ratios, the next 3 are reciprocals of them. AB by AC, AC by AB, BC by AC, AC by BC, AB by BC and BC by AB. So suppose they have given us a right angle triangle and we want to find out these different ratios of the sides. Now when you want to find out the ratio of sides, you should give some name to that, right? That trigonometry is giving us some functions for that. First, let's understand what is the meaning of a function. Function in layman terms or in mathematical. Layman terms, suppose you say your parents, their function is to take care of you. So every function will have a process to do and it will give an output. Mathematically speaking, let us say suppose you have a function by name square. What it will do, you give a number to it, you give x to it, it will square it and it will return you back. So suppose I give 5 to this function, it will square it and it will give me 25. Similarly, these functions, whatever we are taking now, trigonometric functions, these functions take the angle of one angle of the right angle triangle. That means either the angle at A or the angle at C, but not 90 degrees. Any one of those angles they will take, and according to that they will give you the different ratios of sides. Now let us say that for some time that this angle is equals to theta. Now how to understand this AB by AC, BC by AC? For that what we will do? We'll say that okay, now I am looking from here. So this will be my opposite side, this will be my adjacent side, and this is my hypotenuse. Makes sense because you are looking from C. Then AB is opposite to you and BC is adjacent to you and AC is the hypotenuse. So if I look AB by AC, so I can generalize this and say that if you have a right angle triangle and you are looking from one angle, then if you want to know opposite by hypotenuse, or you want to know adjacent by hypotenuse, or you want to know hypotenuse by opposite, you have different trigonometric functions. These functions take the angle as the input of the triangle, and according to that they will give you the different ratios of the sides. Now let us take this example only. Here the angle we are taking is theta. So the first trigonometric function is sine, that will take the angle theta and it will give you opposite by hypotenuse. That is why we write down S is OH. Sine will give you opposite by hypotenuse and it will take the angle theta. Now angle theta is here, that's why this is opposite. Suppose I change the angle theta to here, then this will be my opposite and that will be my adjacent. When we solve some problems, then this will become very easy to you to understand. Let's go to the next trigonometric function. This is sine, we just write it as sin. The next one is cosine, we will write it as cos theta. Now what is cos theta giving you? Cos theta is giving you BC divided by AC. That means it is giving adjacent divided by hypotenuse. So can I say that? Cos is adjacent and hypotenuse. The next we have AB by BC. From this triangle, what is AB? Opposite. What is BC? Adjacent. That means this is giving me O by A, and this trigonometric function is tangent. We say tan theta. Let's have a summary of this. Sin theta will give me O by H. Cos theta will give me adjacent by hypotenuse. And tan theta will give me opposite by adjacent. So looks a little bit weird, but try to remember this. SOHCAHTOA. SOHCAHTOA. SOHCAHTOA means sine is opposite by hypotenuse, cos is adjacent by hypotenuse, and tangent is opposite by adjacent. If you remember this, then automatically you remember these three trigonometric functions. The remaining three will be reciprocals of them. So you know sine, automatically you can find out its reciprocal. What is the reciprocal for sine function? That is cosec. Cosecant, we call it as cosec theta. Because theta is the angle, it is cosec. The next one is reciprocal of cos, that is secant, we write it as sec theta. Then we have tan theta, reciprocal of that is cotangent, we call it as cot theta. Now what are these functions? Let me write down one by one actual names of them. The first one is sine, S-I-N-E. We call it as sin theta. That color is. The next one is cos, we write it as cosine theta. Cosine. The next one is tangent. We say tan. Sine reciprocal is cosecant. We don't write completely. We say cosec theta. The next cosine reverse is reciprocal is secant. We write it as sec theta. Then tangent reciprocal is cotangent. Cotangent, we just say that cot theta. So what we understood till now, what we understood is that if you have a right angle triangle and you know the sides of the right angle triangle, you want to know the different ratios of the sides of a right angle triangle. That is where math is giving us trigonometric functions. These functions take the angle of one of the sides of the right angle triangle other than the 90 degrees, and it will return us the different ratios of the sides of this triangle. Now for that, those 6 trigonometric functions are known as sine, cosine, tangent, cosecant, secant and cotangent. These are the 6 trigonometric functions. How to remember them easily? For that we have SOHCAHTOA. SOHCAHTOA tells us that sine is opposite by hypotenuse, cos is adjacent by hypotenuse, tangent is opposite by adjacent. Now all these are relative to from where you are looking or at which vertex you are, the particular angle you are taking. If you are taking angle at C, then you can write them as sine C, or you know the angle is theta, you can write it as sine theta. Now suppose I am looking from here, then my opposite will be this. My adjacent will be this side and the hypotenuse will remain the same. So you can understand that whenever you are switching from one vertex to the another vertex, the opposite and the adjacent sides are switching. Because when I am looking from here, my opposite is AB, my adjacent is BC. But if I am looking from A, my opposite is BC and my adjacent is AB. Now once you are clear with this, let us do one simple example to understand the concept. Let us go. We'll take a triangle. Let me just cut back to our white color. Let us say this is theta. They have given us a triangle. This is the triangle they have given us, and they said that angle B is 90 degrees. So it will be written that triangle ABC is a right angle triangle, right angled at B, and the hypotenuse is 39. One of the sides is 15. Then find out all the trigonometric ratios. First, let's write down all our trigonometric ratios. Whatever we learned, they are, first is sine. They are asking with respect to theta only. So this is where sine theta, cos theta, tan theta, cosecant theta, then secant theta, then cot theta. What I told you to remember? SOHCAHTOA. Let's see what is that? SOHCAHTOA. SOHCAHTOA. Now if I am looking from here, what will be my opposite side? This will be my opposite, this will be my adjacent, and this is my hypotenuse. It's very simple. You have a right angle triangle, then always the slant, the slide is the hypotenuse. Other two are called as legs of the right angle triangle. In this scenario, they are opposite and adjacent because we are looking from C. Okay, now what is sine according to us? O by H. What is our O here? O is 15, H is 39. Sine theta equals to 15 by 39. Then cos theta, we need to know the value of BC for that. So we will do a little bit of Pythagoras theorem work on that. We will say that AC square equals to AB square plus BC square. What is AC square? 39 square, and that is equals to 15 square plus BC square. We need to calculate the value of BC because we need for cos theta adjacent by hypotenuse. That means we have to give BC by AC. So let us simplify this. 39 square minus 15 square equals to BC square. Can we factorize this as a plus b into a minus b? So I can write down 39 plus 15, 54 into 39 minus 15, that is 24, equals to bc square. Can we get this into small numbers so that we can simplify this? I will say this is 9 into 6 and this is 6 into 4 equals to bc square. So bc equals to 2 6's, 1 6 will come. 9 into 4, 36. Again, one more 6 will come. So we have bc equals to 36. Now once we got bc equals to 36, we can come back and we can easily fill this. What is cos theta? Adjacent by hypotenuse. That will be nothing but 36 by 39. Then what will be tan theta? Tan theta will be opposite by adjacent. Are you able to understand that sine by cos is giving tan? Because OH divided by AH cancels, you get O by A. So basically OA, opposite by adjacent, is tangent, that is nothing but sine theta by cos theta. So we remember that sine theta by cos theta equals to tan theta. What are the other relationships we know? We know three reciprocal relationships. Sine theta into cosecant theta equals to 1. So cosec theta will be reverse of this, 39 by 15. I can fill that easily. Then what is tan theta? We said sine theta by cos theta are opposite by adjacent. What is secant theta? Reciprocal of cos theta, that will be 39 by 36. And what is cot theta? Cot theta is reciprocal of tan theta, so that will be 36 divided by 15. So that is how a simple problem, if they give a right angle triangle and ask us to find out the trigonometric ratios, we can do that. So why trigonometry is a chapter where you are learning for the first time all these trigonometric functions. You look at the any other chapters, you can correlate a little bit with the chapter with respect to the 9th class, or you have an understanding of about that particular chapter. But trigonometry is completely new in 10th grade. If you are coming from CBSE, ICSE, you may learn a little bit in 9th class and continue in 10th class. So let us say with respect to CBSE, this is due in 10th class. Let us do one more example. In this example, we have been given the sides and we have been asked to find out the trigonometric ratios. Let's do couple of more problems on this topic. Then in the next video, we will try to go to the next topic of trigonometry. We have basically three concepts. One is trigonometric ratios. Second, trigonometric ratios of specific angles 0, 30, 45, 60, 90 degrees. And the third one is trigonometric identities, which are really important, which needs a lot of practice. Then only you will be able to solve them easily. They're like solving small puzzles once you know the relation between all the trigonometric ratios. Interesting part. So this is our first topic, trigonometric ratios. What are those trigonometric ratios? What is the meaning of them? What actually they are giving to us and how they are related between them. Let's do one more example. Let us say now the right angle triangle is PQR and we have been given that 15, 8, 17. Oh no, we don't want to do that way, right? Okay, right. I'll just leave it there. And what is given to us? Given to us that 8 tan theta equals to 15. If 8 tan theta equals to 15, looking from here, then find sin R, cos P, secant theta cot r. Let us say this is what we want to find out. Just I created one question for you on the fly. Simple problem it is. Let us see. Now what is the difference between the earlier problem and this problem? In the earlier problem, we have been given the actual sides of the right angle triangle, but here we have been given the ratio. That means we don't know the actual sides, but we know the ratio of the sides. So can we write this as tan theta equals to 15 by 8? I can say that without any problem. Now what is tan according to us? Opposite by adjacent. I am looking from here. That means this is my opposite. Opposite we said is 15 and adjacent is 8. Now you remember we haven't been given the actual sides. We have been given the ratio. So I will attach k there. Then if you do Pythagoras theorem, then you will easily get that this is equals to 17k. Now what information has been asked? What is sin r? Sin r. That means you are looking from here now. If I look from here, what will be my opposite? Opposite will be 8k and hypotenuse is 17k. kk cancels. I can say that sin r equals to 8 by 17. Then what is cot r? Cot r is reverse of tan r. Tan r is opposite by adjacent, then cot will be adjacent by opposite. With respect to r, what is the adjacent? 15. What is opposite? 8. So 15k by 8k, we can cancel k and k and we can say that is 15 by 8. What is cos p? Cos p means you are here now. From here, what is your adjacent? Cos. So cut over. Nothing wrong in writing down every time when you do trigonometry. There are so many ways of remembering the trigonometric functions. This is one of the way. You can make it desi also. You can just write whatever you want. So the point is you have to remember how those trigonometric functions are related to each other. One of the way is so cut over. So cos is adjacent by hypotenuse and p is the angle where I am looking from. Adjacent will be 8 and the hypotenuse will be 17. So can I say that cos p equals to 8k divided by 17k. kk will cancel. 8 by 17. Then secant theta. Either I mention p or I take a angle theta. Both of them are same because if the angle is not given, I'll take the vertex. If the angle is given, I prefer angle, or you can also go with vertex, no problem. Secant theta will be nothing but reverse of cos, we know that. So we can say 17 divided by 8. Now that is another example, simple example. What we have done, we have been given that 8 tan theta equals to 15. We have to find out what is sin r, what is cot r, what is cos p, what is secant theta. When it is sin r, we are looking from here. So opposite will be this. With respect to r, adjacent will be this. With respect to r, if you are looking from p, then that will be opposite will be the same like this one and the adjacent will be this. So sin r looking from here 8 by 17. Cot r, that is adjacent by opposite, that is 15 by 8. Cos p looking from here adjacent by hypotenuse. And secant theta reverse of cos theta or cos p, that is 17 by 8. Let us do one more example. After that, we will close this topic and this particular session. In the next session, we will go to trigonometric ratios of specific angles. One interesting problem we will do. Let me create one problem for you right now. One side of a right angle triangle is 7 and the other two sides difference is 1. xz minus xy equals to 1. yz equals to 7. What you need to find out is what is sine square x plus cos square x, what is secant square z minus tan square z. You also need to find out these two. Okay, we can just leave it there. First, we have to know the values of the sides of the right angle triangle. Then only we can go for, with respect to angle x or z, how to find out the trigonometric function. So let's do that. We have been given that xz equals to xy plus 1. That should be in capitals actually. Hypotenuse. So let us say this is x and this is x plus 1. X and x plus 1. Let's apply Pythagoras theorem now. Can we write down? X plus 1 can we write down? X plus 1 whole square x plus 1 whole square equals to x square plus 7 square. Let's open the brackets. We have x square plus 2x plus 1 equals to x square plus 49. X square cancels. We get 2x equals to 48. X equals to 24. If x is 24, then what will be x plus 1? 25. That means the sides of this right angle triangle are 24, 7 and 25. Now whatever information they want, we can easily find out. Sine square x plus cos square x. What is sine x? If I am looking from here, what is my opposite? 7. This is 1, 7 only. Opposite will be 7. 7 divided by 25 whole square plus cos x. Cos x is adjacent by hypotenuse. With respect to x, it will be 24 by 25 whole square. Simplify that, you will get 1, because that's a trigonometric identity what you are going to learn after 2 classes. Then what is secant square z minus tan square z? Secant square z, that is cos z reciprocal. What is cos z? Cos z is 7 by 25. So this guy will be 25 by 7 whole square minus tan square z. With respect to z, this will be my adjacent and this will be my opposite. So tan will be opposite by adjacent, so it will be 24 by 7 whole square. And when you simplify that, you will again get 1. So what we understood about a little bit about trigonometric functions, how they are defined, what is the relation between them, and the simple examples, so that we can apply the concept whatever we learned in this particular session. So that is about the first topic of trigonometry, trigonometric ratios. In the next session, what we will do trigonometric ratios of specific angles. That means with respect to sine, what is sine 30 degrees, what is cos 45 degrees, what is tan 60 degrees, and what are those values, and some problems applying that particular concept. So I'll see you in the next video. Thanks for your time and support. If you are